Alright, this video is for lesson 9.8 notes. This is going to be the effects of dilations on volume. So we're going to do this two different ways. So here we've got a big cylinder and a small cylinder. So on this column it says, what is the ratio of figure A to figure B? So we can compare those. Figure A to figure B. You pick the same measurement. So let's pick the radius. A to B would be 12 to 3. And to write that like a ratio, I write it like this. I could also write it like a fraction. So if I write it like a fraction, it would be 12 over 3. And so that simplifies, okay? So how you simplify a ratio, 12 is divisible by 3. So 12 divided by 3 is 4. 3 divided by 3 is 1. Ratios will not simplify down. So you can see here, it's simplified down just to a 4. You have to have both pieces. Now 4 is a fraction. You can write it as a fraction, 4 over 1. All right, now we're going to do, try to get this where you can see everything a little bit better. What's the volume of figure A? So cylinder is pi r squared h. So figure A has a radius of 12 and a height of 28. So when I do this, I'm just going to do pi, so radius is 12, height is 28. I'm going to do this in terms of pi. Again, it just makes the numbers easier to work with. And so 4032 pi inches cubed. Right? What is the volume of figure B? So same thing. The radius up here is 3. The height is 7. So again, I'm going to answer in terms of pi. And I get 63 pi inches cubed. So it says, what is the ratio of volumes of figure A to figure B? So we would just write that. I'm going to do it like this, 4032 to 63. If you notice, I dropped the pi's. The pi's cancel each other out in the long run. I want to simplify that though, so I need to type it in like a fraction. 4032 over 63. I get 64. I am so sorry, guys. I do not know why that is running crazy today. But remember, I have to use two numbers. So 64 over 1. All right, the other side, we've got cubes. So this one wants to know what's the scale factor from G to H. So this one is a ratio. This one is a scale factor. So to find a scale factor, we do image over original. So all the sides are going to be the same. So just pick a side. And again, we're going to write it like a fraction. Okay, kind of rearrange here again. There we go. All right, so 12 over 7.5 simplifies to a scale factor of 1.6. That means I can multiply a side by 1.6 and get my new side. And then what's the volume of G? So for cubes, we can just cube a side length or multiply length times width times height. Gives us the same thing. So 421.875. This is going to be feet. And then the volume of figure H, it's 12. So that one is 1728 feet cubed. And then it says, what's the scale factor from G to H? So again, image over original. Image is always the second one. So from G to H, image is always going to be H. So I would take H and write it over G. And I get 4.096. All right, at the very bottom, it says, what conclusion can be drawn about the relationships between dilations and volume? So we want to look and see how the scale factor changed. So here, the 4 became a 64, and we have to say, well, how did we turn a 4 into a 64? And it can't be multiplication, because you have to be able to do the same thing to the 1. If you multiply the 1 by anything, it's not going to change. So it has to be an exponent. So 4 squared is 16, 4 cubed is 64. The same thing happens here. If I take that scale factor and I cube it, I get the scale factor from the volumes. And so just like when we did area, when we're doing volume, we can cube the scale factor. So the scale factor must be cubed in order to apply it to the process of finding the volume of a dilated figure. So that's it for this set of notes.